Hello everyone and welcome back. This is Safa. In this video, we're going to explore the effect of pole location on the step response of first order systems using MATLAB. You'll see how moving the pole changes the speed of response while keeping the final value constant. Okay, here. First, we clear the workspace command window and close all figures. CLC clear and close all. Okay, now here we define three different pole locations for our first order system. Minus 0.5 slow pole, -1 medium pole, and -3 fast pole. Okay, next, we define three transfer function with unity DC gain so that all systems settle at the same final value of 1. Okay, and here we display each transfer function for clarity. Finally, we plot the step response of all three systems on a single figure. Okay, run. Okay, you can see a command window. System with pole at -0.5, -1, and here -3. Okay. Okay, let's look at the results. The blue curve here, pole is -0.5, rises slowly. Here we can see from 0 to 1. The orange curve pole is -1, rises faster. And yellow curve pole is -3, reaches 1 the quickest. Okay, all systems settle at the same final value without overshoot, clearly showing how the pole location affect speed but not steady state value. Okay, as you can see, moving the pole further left in the S plan makes the system response faster, while closer poles result is slower responses. This is a fundamental concept in control system design and helps us predict system behavior intuitively. Okay, in the next video, we will explore the effect of zero on system response. Thanks for watching.